Resource
Hello
usage
everyone
is
and
measured in
welcome to our
terms of
presentation on
CPU and memory,
protocols
similar
used in
to
Internet of Things
performance and
presented by
energy
myself
characteristics.
Sweetam and my partner
CPU
Shreyas.
usage of
As we all know
MQTT-SN
that the
increases
Internet
when
of
the
Things
client
is really
is
transforming the way
connected to
we interact with the world
the
around
local
us,
and Oregon
and
server
protocols
as the
have a
packet size
major role to
increases.
play in
Java
connecting
heap
and
usage,
managing
which
these
measures
billions
memory,
of
is
new devices
consistent
around us.
regardless of
By
physical
2020, it is
location of
estimated that the
servers
Internet
for
of Things will
TCP
grow
and
to more than
WebSocket.
27 billion
Co-op
connections across
requires
the globe,
more
and
memory
we're just getting
than
started.
other protocols
As
when the
Internet of
client is
Things
connected
comprises
to
of
Oregon
billions of
and
devices,
Tokyo
and these
cases.
devices
Such patterns were not
communicate with
observed
each
in
other, there
performance,
must be
energy
standardized
efficiency, and
languages
CPU time
which these
experiments
devices
due to
understand in order to
fragmentation. The
communicate
results
efficiently.
show that
In other words,
co-op's
there must be standardized
retransmission
protocols
mechanism is
which
mainly
these
affected by memory
devices
usage
incorporate
rather
in
than
order to
CPU
efficiently
usage.
communicate. So, protocols play an important role in the success of connecting
The
these
results can be
billions of
looked at
devices around us
as
in a
when the
reliable
distance of
and secure way
when the
with
distance between
minimum
client and
costs of
server
production
increases,
and
the
deployment,
experiments show
along
that
with longer
MQTT
battery
and
life.
co-op
Thus,
protocols are largely
protocols
affected
is an
by packet
interesting
size.
area to explore
Co-op and
when it comes
MQTT
to the
start
domain
to
of
fragment
Internet of
a
Things.
packet from 1
We will
kilobyte
start with
and
LP1 as the
1.5
first
kilobytes
topic on our discussion
respectively.
about protocols.
If an application
LP1 stands for
utilizes
Low
MQTT
Power
protocol,
Wide Area
the packet
Network.
size
They
should be
connect
up to
objects wirelessly
1.5
over
kilobytes for
miles for
performance and
several
energy
years, and the
efficiency.
battery
If a
is very
programmer
low.
wants to use
Why so?
REST-like
Because
APIs,
legacy
the
wireless
packet size
network
of co-op
technologies,
should be less
unlike
than 1
LP1,
kilobyte to
have
avoid
been
performance
designed for
or
very
energy
different
overheads caused by
purposes
error
than
recovery.
connecting tens of
Co-op
billions of
employs a
objects.
straightforward
LP1
retransmission
supports large
mechanism
distances
using
up to
exponential
tens of
backoff time
kilometers. The
on top
key
of
feature is
UDP,
that it
while
supports long
MQTT
range
relies on
but comes
TCP
at the
error
cost of
recovery
reduced
mechanism.
data rate.
Due
Only
to poor
applications
implementation,
where data transmitted by
MQTT-SN is
sensors
not
are
ready
very small
for
in terms of bytes,
real-world mobile
but it
software
needs to be
development.
transmitted to tens
TCP
of
and
kilometers,
WebSockets
will be
often
benefited
outperform
by LP1. A
IoT
typical example of such
protocols.
an
In
application
conclusion,
is
we
monitoring
can
city
say that
garbage in real
the
time and
challenges
determining
of
when they are full.
choosing
These
an
data of garbage bins
appropriate
travel
communication
several
protocol
kilometers to
for
reach
resource
to
constrained
municipality offices.
application remains.
Accordingly, it enables
We have
city planners
compared the
to optimize
performance,
collection
energy efficiency,
schedules
and resource
based on
usages
where
of
collection is actually
5
needed,
different network
resulting in cleaner cities
protocols.
and cost savings through
The
improved
experimental
operational
setup
efficiencies.
consists of one client
As
and three
explained
servers
earlier,
located at different
LP1 is
physical
best suited
locations.
for those
These are
applications where
local,
data rate is
Oregon,
low,
and
that
Tokyo.
is, the bandwidth requirements are really less, but
The
transmission distance ranges
provided
are quite
table
high.
looks at the
Other wireless
various
communication protocols
protocols and the
like
libraries
Bluetooth,
which are used in
Zigbee,
the
and
experiment.
others shown over here have higher
The
bandwidth
algorithm shows
requirements,
how
and thus
each
the
protocol
distance
is
range
assessed in
is
terms
less.
of performance,
So the sweet spot
resource
for
usage,
LP1
and
is
energy efficiency on the
lower
client side.
bandwidth
The
and
benchmark of
higher range of
application
communication.
sends data to a remote server
Many
using
LP1
different
customers
packet
have
lengths
previously
ranging
tried
from
to solve their
128 bytes
wireless
to
connection problems with mesh
1920 bytes.
topology networks like Zigbee. They struggled
Looking
with mesh
at the
network solutions
performance
because of
metric,
high data
we can
rates,
conclude that
which resulted
TCP
in
and
lower link
WebSocket
budgets.
protocols show
Link
the
budgets,
best
data rates,
performance
and
across all
receiver
benchmarks.
sensitivities will be covered in detail in
MQTT-SN
the
shows
upcoming
the
slides.
poorest result
So instead
in the
of a
local and
mesh
Oregon
topology
cases,
network,
while
most LP1
MQTT's
technologies
performance
rather use a star
increases
topology
with
network.
increasing packet size.
Repeaters can be used to
Co-op
fill in gaps in
performs
coverage,
better
which
than
for most
MQTT and
applications is a
MQTT-SN
good
as
middle
long as
ground
its
in
packet size
terms
is
of
less than
latency,
1024 bytes. For
reliability,
larger packet
and
sizes,
coverage.
transmission
We
time
will cover some of the
increases
basic concepts related to
for
LP1.
co-op, as
They
can be
are
seen from the
link
graphs.
budgets, data rates,
This is due
and
to
receiver
the
sensitivities.
fragmentation of
Link
larger
budget is the
packets into
measure
smaller
of the
blocks.
amount of energy that is detected
MQTT-SN
at the
and
receiver
co-op are
side.
not suited
Larger transmission
under
power
limited
at transmitter
network
side or
conditions.
higher
We
sensitivity
can
at receiver side
conclude
can
that
result in better link
for
budget.
larger packet
Data
sizes,
rate and amount of
MQTT
energy
is
per symbol are
preferable over
inversely
co-op.
proportional. Energy per bit is the main lever to change the possibility of a
When
message
it comes
being
to
heard.
energy
To
efficiency,
achieve this in LP1,
TCP and
the
WebSocket
modulation rate
protocols
and
are
data rate
unaffected by
are reduced
physical
to
location of
half,
servers
which
having
results
different
in
delay
putting
or
twice as much
bandwidth
energy
characteristics.
into
Co-op,
each symbol,
MQTT, and
thus increasing the
MQTT
overall link budget. So
SN
this is the key
have low
mechanism followed
energy
in
efficiency
LP1
due
to
to
support
underlying
larger distance
uh,
of transmission with lower
transport
data rates.
protocols packet
These principles of
fragmentation, and
LP1
poor
are implemented
implementation,
by many
etc.
groups like Sigfox,
As can
LoRa, NB-IoT.
as in the
Here is a brief
performance
summary of it.
experiment,
As you can see,
co-op's energy consumption
the
increases
Sigfox
with
is
packet
really
sizes
low
greater than
power, but the bandwidth
1024
is not
bytes.
as great as
When the
LoRa,
packet size is
and
larger than
it's a bit open
1024
standard in
bytes
that it does
for
not restrict the use
MQTT in
of
the
confined
Oregon
hardware.
and Tokyo
It is
cases,
open to any kind
it
of hardware,
consumes
even in
lesser energy
Arduino
than
also it
co-op.
can be simulated, but LoRa it restricts
For
because it's not that open and it is only
relatively
applicable
larger
on
packet
chips
sizes,
which are
MQTT should
manufactured
be
by the LoRa.
favored
And
over
as we
co-op.
can see the other
This
factors are
result is
linked in the
analogous
following way.
to the one
But
obtained in the
as you see, the
performance metric
deployments of
experiments.
NB-IoT is not as good as LoRa and Sigfox because Sigfox and LoRa are widely distributed across France and major parts of Europe, but that is not the case with NB-IoT.
Hello friends, today we're going to discuss about the various IoT protocols and their suitability for resource constrained applications. Uh, IoT applications are operated in various networks, wireless networks, in a variety of constrained environments in terms of network conditions and limited hardware resources. Uh, for example, the demands of small wireless IoT networks or devices are outstripping battery lives. Thus, energy efficiency, performance, resource usage become important software design considerations. This, this paper aims to provide certain guidelines to programmers when they go about choosing about uh, various IoT protocols for setting up network communication. Uh, the protocols we are going to be considering are constrained application protocol, message queuing telemetry protocol, MQTT sensor network, WebSocket, and TCP. In this paper, we aim to analyze how different protocols behave under different network conditions and with different message sizes. And IoT designers also need to be aware of how to go about choosing protocols for their applications. And our third aim is to uh, look for areas of improvement in performance and energy efficiency in designing newer emerging protocols. Before we compare IoT protocols, we can have a brief discussion of the protocols themselves. Firstly, we consider Constrained Application Protocol. It was designed by the IETF to connect devices with different constraints and specifications. As the name suggests, it's an application layer protocol. It overcomes the limitations of HTTP protocol, which is not suitable for constrained environments, and it's built upon UDP and it's built upon UDP and it's suitable for constrained networks and nodes. Uh, Next, we look at the message queuing telemetry transport protocol. It was designed by the Organization for the Advancement of Structured Standards. It's a lightweight protocol in the application level and is based on publish subscribe architecture. It's particularly suited for constrained devices in low bandwidth, latency, and unreliable networks. It attempts to ensure reliability and assurance of delivery of messages. It is based on TCP/IP. MQTT-SN is another protocol which is used in low bandwidth wireless environments, and unlike MQTT, it's based on UDP, and it's not suitable. It's not well supported as of now. And going to WebSocket, it is again designed by the IETF and provides two-way communication between browsers and servers based on TCP. It was originally designed to supersede HTTP, but nowadays it has gained importance in the domain of IoT communication protocols. Before we compare the various protocols, we need to look at the definitions of metrics by which they are compared. Performance. By performance, we mean the time needed to send messages and receive their acknowledgements. Energy efficiency means the time consumed for a given total energy consumed for a given execution time. Resource usage means the average Java heap usage measured every 500 milliseconds and the total CPU time.